Guys, welcome to day 9 of your pre-cal video notes. Today we are going to be talking about trig functions of real numbers. Alright, so we're going to kind of continue from what we were doing last time. So we're still going to be working with the unit circle and various trig functions of different angle measurements. All right, so this warm up. Given that the hypotenuse of each triangle is 1, determine the side lengths of the triangles and the xy coordinates of the point on the edge of the circle. Okay, well, looking at this very left-hand unit circle here, we see that we have already all the sides labeled on the triangle. So we don't have to find the sides. And if you recall, whatever is the horizontal length or direction, that is going to be the value of cosine of the angle, and whatever is vertical, that length of the triangle will be equivalent to sine of the angle. And so essentially cosine of the angle is our, what we kind of usually, sorry, my cat's got the zoomies this morning. So what we think of normally as kind of our x coordinate value in the coordinate pair. So for cosine of the angle, that horizontal distance, that's in the x direction. So that is our first value we're going to write down, just like a regular coordinate pair. We write it down x comma y. And then our vertical value, that's going in the y direction. And that is also then root 2 over 2. Okay, looking at the next triangle. Once again, we're given both of the angle, or both of the side lengths, 1/2 and root 3 over 2. And so this 1/2, that is going in the x direction, horizontal direction. So that's going to go in our first position of our coordinate pair. And then root 3 over 2 will be our y position. All right. And then notice the third one, we don't have the side lengths actually given to us, so we're going to find those first, and then we will state what the coordinates pair is. And remember, guys, each time we're stating this coordinate pair, what we're doing is we're stating where the position of this point here would lie on our unit circle graph here. So, you know, just like we graph normal functions, there's an x and a y axis, okay? And if you just imagine that this circle and triangle is in here, and just this point is, just imagine it being like any other plotted point on a graph. And we know all points have a coordinate pair, right? An x and a y value. So it is just like that, except now with the unit circle, it happens to actually land on the line of this circle. Okay, so we know for this third circle, we have the radius. We also have our 30-degree angle. So I'm going to use that angle to help me find out my values. So let me just go ahead and I'll call this side A, I'll call this side B. Okay. And so I'm going to use the angle. Let me just say I'll find B first. Okay, so what I'm doing right now is finding the length from here, the x-axis, all the way up to the point on the circle. All right, well, given my angle as 30 degrees, I know that from this 30-degree angle, B is the opposite side, A is the adjacent side, and then the radius is always going to be across from the 90-degree angle. So I have sine of my angle, so I'm finding B first. So sine of 30 degrees equals opposite over hypotenuse. So opposite of the angle is B over the hypotenuse, which is 1. All right. Well, anything divided by 1 is just itself. So whatever sine of 30 degrees is, this is equal to B. All right, and we have talked about the unit circle before. You guys do have, fully filled out unit circle. So even though I am doing this by hand, kind of how we talked about in class, you could also, once you have your unit circle memorized, this would be a value that you would know from memorizing the unit circle. So if you also look at the filled out unit circle and look at sine of 30 degrees, you'll see what is given in that second position in the coordinate pair. All right, but let's just say I didn't know. So I'm going to take my calculator, my graphing calculator, and I'm typing in sine of 30 and making sure I'm in degree mode. And so when I do that and hit enter, I get 0.5, which means sine of 30 is 1/2. So that's going to be the value of that second position in my coordinate pair. All right, now I want to find A. Well, there's a couple ways you could do that. You could either do the same thing, cosine of 30 is adjacent over hypotenuse, or now that we have two sides of the triangle, we could use Pythagorean theorem. And that's actually what I'm going to do. We know the Pythagorean theorem is a squared plus b squared equals c squared. Well, I'm looking for a squared. B is 1/2 and c is 1. Okay, so when I'm simplifying this, 1/2 squared, well, 1/2 times 1/2 would be 1/4. And then 1 squared is 1. Then I'm going to subtract 1/4 from 1, and that will give me 3/4. Then I need to take the square root of both sides. And we only have positive values here in this first quadrant, so I'm not going to worry about doing any plus or minus or anything in front of the square root. All right, and so when I do that, I have a equals, I have square root of 3/4. Now that's not fully simplified, and so there's a rule, a property that says that if we have a square root of a whole fraction, we can break it apart into two separate square roots. So square root of 3 on top, and then square root of 4 on bottom. So notice I just broke it apart into two separate square roots. Well, we can't take the square root of 3, so that will stay as is. But on the bottom, square root of 4 is 2. And so we have found our value of A. All right. So this next little part here, this is, obviously the unit circle. We've mentioned this to you guys. You do need to have it memorized. And ideally, right, we'd want to be able to say all of those values on the unit circle that we see without actually looking at it. And so there is a little hand trick. I'm not going to go into it right now. We mentioned it in class. You can, if you ever forget or you want, whatever the case may be, you can always look on YouTube, hand trick for the unit circle, and a million videos will pop up. Okay. So let's just talk about the fact that we know what else we know about the unit circle. So the unit circle is a circle of radius 1. Okay, we know that. It's centered at the origin in the XY plane. And the equation of the circle, and you've actually worked with circles before. Back in, we didn't get to it last year in Algebra 2, but back in geometry, we worked with these. So this equation of a circle is x squared plus y squared equals, and so we're always equal to the radius squared when we're writing the equation of a circle, but 1 squared is just 1. Okay, so there is our equation of the unit circle. Okay, so let's show that the point given is on the unit circle. Okay, so we're going to use the equation of the unit circle to determine, is this point on the unit circle? All right, so we have an x value and a y value, so we are going to substitute those in for our variables. Okay, and now I'm going to solve. So I have root 5. So remember, when we square something, what we're doing is multiplying it by itself. So, and we multiply fractions straight across. So root 5 over 3 times root 5 over 3. Well, on top, root 5 times root 5 is going to give me just 5. If you remember when we were rationalizing before, whenever we multiply two square roots and they have the same number underneath, it just equals that number underneath. So we have 5 over, and then in the denominator, 3 times 3 would be 9. Plus, and then now the second fraction, negative 2 times negative 2 on top would be positive 4. And then 3 times 3 would be 9. We'll add these together. Remember, we leave the denominator the same when adding fractions. Since we have a common denominator, we can go ahead and just add straight across the top. And 9 over 9 does indeed equal 1. All right. And so the fact that we just showed that this does equal 1, that means that yes, this is on our unit circle. All right. Let's do another one. We are given a point, and we know it's in quadrant 3, and we're going to find its y coordinate. Okay, so first off, guys, just a little recap. Looking at this unit circle, we say quadrants as we go counterclockwise, just like we do when talking about positive angle measures in the unit circle. So going clockwise, we have quadrant 1, 2, 3, 4. Okay, and something, very important, again, that we've talked about is which trig functions are going to be positive and which trig functions are going to be negative on the unit circle. And so, just like we have, I'll recap that. So for this first quadrant, okay, to get to some point, we actually have a line drawn. To get to that point, we would go in the positive x direction and the positive y direction. So both of sine and cosine, remember they represent, cosine of the angle represents the x value, sine of the angle is the y value. So both of those would be positive. And if both of those are positive, so let me write cosine we do have a third trig function we end up using at various points, tangent. So I'll actually go over that later when we come to it, but tangent would also be positive as well. Quadrant number 2, we would have to go, let's just say that's our point, we would have to go backwards in the x direction and positive in the y direction. So that means that cosine will be negative and sine will be positive. The third quadrant, we would, again, just like quadrant 2, have to go backwards in the x direction, and then we'd go down in the y direction. So both cosine and sine will be negative. Okay, and then quadrant 4, to get to point on that, in that quadrant, we would go positive in the x direction, down in the y direction. So positive in the x direction makes cosine positive, down in the y will make the sine negative. Okay, and so that's really important because once we find y, we have to determine for ourselves, is that going to be positive or negative based on the quadrant that it falls in. Okay, so we're given a point. I'm going to use the equation of the circle To find it, remember it's super important, it does say that it's on the unit circle. Otherwise, you can't use the equation of the unit circle. So I have negative root 2 over 3 squared plus, we're going to find y squared equals, and we know that the radius squared is just 1. All right, so then I'm going to go ahead and evaluate this. So I have negative root 2 over 3 times negative root 2 over 3. Well, negative root 2 times negative root 2 becomes a positive, and then just 2, we can drop the root. 3 times 3 on the bottom would be 9. Okay, and then I'm going to subtract 2/9 from 1. But I need a common denominator to do this subtraction. So instead of writing 1, I want it to have a denominator of 9. So I'm going to write it 9 over 9. All right, and then 9 minus 2 gives me 7 over 9. And so when I set y squared equal to 7 over 9, I'm going to take the square root of both sides. And just like before, I can break apart my fraction into 2 separate square roots. So that would be square root of 7 over 3. And then when I, in this case, before I told you, if you remember, I didn't need to write the plus or minus in front. I knew that I was in the first quadrant in that warm up on that third circle, so I knew it had to be positive. But in this case, we're in quadrant 3, so let's figure out, okay, are we positive or negative for this y value? Well, if we just, so quadrant 3, that's going to be this quadrant here. I know that my x value for cosine, that's negative, and the y value for y is also going to be negative. Okay, so we have a negative x, negative y, so that means I'm going to take the negative of this y value and write my coordinate pair negative root 7 over 3. Okay. All right, so since the arc length subtended by an angle is as such, we did that on the last notes, and the unit circle, the radius is 1. For this lesson, the distance around the circle to the terminal point is called t, and it corresponds to the terminal side of the angle because as such. The point that is t distance around the unit circle from 1, 0, so that's that value right here, is called the terminal point of t, okay? So in other words, let's just say I start, here at this red dot. I'm gonna go counterclockwise. Let's just say I'm gonna stop right here. So I went all the way around, stopped at this point, and so that means I've created this angle measure. Okay, and so the terminal point is the ordered pair on the unit circle where the angle terminates. Okay, think like terminate, we're stopping something. So our stopping point on the unit circle, so the second point here, that's what we would call a terminal point, and it's that ordered pair where we of that point. And then remember, we do sometimes go in the negative direction, so clockwise. So that would be if I started, you know, same space, same spot, but then went clockwise and created this angle here. Okay, then that would be the terminal point down below. All right, so let's draw a picture and find the point on the unit circle that corresponds to each given value. Okay, so we're gonna find where pi is. So starting here, pi would be if we went all the way around and then stopped at that point there, okay? And that point is -1, (0). Right, we went -1 in the x direction, and then we didn't go up or down at all, so that's why the y is 0. All right, now let's do part B. So we have -pi/2, so that means that we are going to go in the negative direction since our angle measure is negative. So starting on the x-axis, I'm going to go -pi/2 and stop at that line there. And so that would be, we wouldn't have moved anywhere in the x direction, but we went down 1. So that point 0, 1, just like you see there. All right, 5 pi. All right, well, we know a full rotation is 2 pi. So if I start here on my x-axis, I'm going to go counterclockwise. So if I go around the circle all the way, just one time, that's 2 pi. Now I'm going to go around again. That's another 2 pi. So now I've got a total of 4 pi. So I have 1 pi left to get to 5 pi. So I'm not going to go all the way around. I'm just going to add 1 more pi. So that means I'd be stopping right here on my unit circle. And so that value is -1, 0. All right, now we have 5 pi/4. The directions say draw a picture and find the point on the unit circle that corresponds to each given value. So just like we were doing, except now we're going to be working with radian measures that won't fall exactly on the axes. Okay, so what I would say to do here, and I probably will erase this because I don't want to take up too much time, or not too much time, too much space. So notice that we have 5 pi/4, okay? So what I like to do is I like to split each half of the circle into 4 equal parts. Then count 5/4. Okay, so by that I mean, so starting at my x-axis here, okay, splitting my circle into, or each half into 4 equal parts. That will give me, okay, so there's 1, this would be 2, this would be 3, 4, and if I do it to the bottom half, 1, 2, 3, and then that's my 4. Okay, And so if you notice on your filled out unit circle, every 45-degree angle measurement we go, so this right here would be 45 degrees, then we'd go another 45, then another 45, so on and so forth. All of those angle measures on the unit circle have the radian values of over 4, or at least a simplified version of a fraction that was over 4. Okay, so by that I mean right here, that's 1 over 4, 2 over 4, 3 over 4, and then we come to a full pi, so that's 4 over 4. And then we have to go one more to get to 5 over 4. And I didn't write pi on all of these. And so we have our spot given right here. Okay, so that means we went all around and stopped right there. Okay. And so now, let me just move this up. And so now what we're going to do, right, we found the position on our unit circle, but we need to find the point that corresponds to that. So what I'm going to do is next draw a triangle and decide if it's a 30, 60, 90 or 45, 45, 90 triangle. And so that would just be like, I know I already told you that these were 45-degree increments, but if you didn't realize that right at first, then referring to your unit, then looking back at your unit circle, right, we know that this is going 45 degrees from the x-axis. And so, yeah, if I just have a triangle drawn here, we know this is the right angle, and we know then both of these angle measures in that triangle are going to be 45-degree angle measures. So we have a 45, 45, 90 here. Okay. And if you actually look at the degree measure on your unit circle, you'll see that it's equal to, we know that this guy's 180, or in other words, pi. You'll notice that the degree measure of this 5 pi over 4 is 180 plus 45 degrees, so 225. Okay. And so now we want to actually state what is going to be that coordinate pair. So I ran out of room a little bit. Okay, so that coordinate pair, you can either, if you have your unit circle memorized, that I would start trying to practice stating what that coordinate point would be without looking at your unit circle. But if you even just look at the unit circle to double check yourself, right, you'll see that this point here at 5 pi over 4 is negative root 2 over 2 because we go in the negative x direction backwards. And then we'd have to go down in the y direction, so that would also be negative. And there's our coordinate pair. All right, I'm gonna go a little faster on these next ones. So now I have negative 2 pi over 3. So I'm gonna go in the negative direction, so clockwise. And so if I, anytime I see something over 3 or over 6, I know I can split my unit circle into, just like I did how I split each half into 4. For this one, I would split each half into 6. So either I'm splitting the halves into 4 or I'm splitting them into 6. So if I split these into 6, that means I need, let's see, it's going to be 1, 2, 3, 4, 5, 6. And then on my second half, 1, 2, 3, 4, 5, 6. Okay, so I'm gonna start on the x-axis, go clockwise though. I need to count negative 2 pi over 3, which is because remember I'm either doing it into 4 or 6, so this was a fraction that was simplified. And it originally had a denominator of 6. So another way, so if I change it back to 6, that means I'd multiply by 2 on bottom, multiply by 2 on top. So I'm going to count, right, and that's equivalent to negative 2 pi over 3. So I'm going to count negative 4 spaces. Okay, so starting on the x-axis, I have 1, 2, 3, 4. Oops. Oh, I was going to keep going. Oops, yeah, so 1, 2, 3, 4, and there we go. And I'm going to stop right there. Okay, and so the point on that unit circle, that would be where we went negative in the x direction, down in the y direction, so both values are negative, just like in our first example, and it would be negative 1/2 negative root 3 over 2. Okay? And again, I recommend take out your unit circle, double check that that value there would be correct. Okay, so last one, we have 25 pi over 6. And so this guy is obviously extremely large and well above 2 pi. So we want to find a coterminal angle, so I'm going to basically just subtract 2 pi until I get to a value that's between 0 and 2 pi. Okay, so I'm not going to do it for the entire time, but if I have t 25 pi over 6, I'm going to subtract 2 pi. And I'm going to keep doing that until I get down to the angle that is between 0 and 2 pi. Well, I need a common denominator. So if I want my denominator here to say 6, then I also need to, right, that would be 1 times 6. So I need to multiply my 2 times 6. So that's 12. Well, 25 pi minus 12 pi, that's going to get me 13 pi over 6. Okay, and then I would do the same thing, minus another 12 pi over 6 because I'm not quite in my 0 to 2 pi range. And when I do that, 13 minus 12 is 1 pi over 6. Okay, so my coterminal angle is pi over 6. Okay, so on the unit circle, that's going to be, oops, up to there. That would also be 30 degrees, and the point at that, or the coordinate pair of that point is root 3 over 2. It's positive because to get to this point, we would have to go positive in the x direction, and then we would go positive in the y as well. Okay, and so here's how we can find coordinate pairs, those points of real numbers on this unit circle. Okay. All right, so I'm gonna just stop this one right here for now. So this will conclude part 1 of the notes. and then we will have a part 2.